Hello everyone, I'm Xiao Gang. Okay, in this lesson, we will mainly look at the programming subsystem. Then our basic support should be coming to an end soon, because there isn't much left after this. So, the programming subsystem, and then we'll briefly cover smart pointers. Also, there's still assertions that haven't been covered yet. I see that assertions haven't been covered yet. As for the rest, we can then move on to slightly more complex topics like multi-threading and things like that. After finishing multi-threading, we can officially start to get into some slightly commercial case feature implementations, because these things come in sets. If we don't cover the basics first, everyone might not understand. What is this system? It's called subsystem. It is essentially a singleton with a controllable lifecycle, a globally unique singleton, and we can use it in both Blueprint and Python. Its advantages are it actually replaces a related function of our GameInstance. Because our game is essentially GameInstance. It is our God class. Let's check if our project has specified GameInstance. We find it here. It should be here. There is a GameInstance. We haven't specified it yet. So now let's simply create a tower. We'll just place it here. That's fine. Because GameInstance is very important. We will often do things in the game instance. What kind of things? We will store some global game data. For example, some player IDs. Then the player's account information. And the some save files, etc. We often do this in the game instance. It should be very simple, but it is very important. These are when connecting to the network. These overloaded functions will be triggered. Your Blueprint teacher must have taught you how to do saving. It has a dedicated, excellent save serialization mechanism. But if you put a lot of things in the game instance becomes particularly complex and redundant. For example, if you want to implement a scoring system, you may constantly switch levels. Once you switch levels, your gamma mode, cast, player, controller, player state, all of these things will be destroyed. The scene will be destroyed, and then a new set will be generated. And the gameplay framework, but GameInstance will not. So you put your scoring or level transition order into the game instance. It's very convenient, but if you put too many, after putting too many, this game becomes particularly bloated. Actually, I still have some features. For example, I need to upload images, I need to send emails, and then I need to process payments, or I need to store things. When you are doing some relatively independent functions like these, then you have no way to write them into the game mode, and you can't write them into the actor either. So the only place you can write them is then you have to write it into your object. But at this point, you need to create such a unique proxy. Actually, you will find that our GameInstance, it also inherits your object. Then you need to write your object yourself. And at the same time, you need to find a place to mount it. So you can actually create a pointer in GameInstance. Then after GameInstance initialization is complete, point the pointer to your own new object and instantiate it. When the game ends, then release your own defined new object and free it. This is a very reasonable approach, but think about it. If everyone, each project, each team, as long as they have a single demand, they all write it this way, then it will be managed by the lifecycle. It is not very standardized. Based on this, UI proposed several types. Lifecycle management of the life system. As for this subsystem, it is consistent with the engine's lifecycle. As for the editor, actually it is when we were under the editor. That's how it is. Then in the game runtime, it is consistent with the lifecycle of our game instance. Also, this local player is ULocalPlayerSubsystems. As for the specifics, actually, this is quite complicated to explain. Then you can take a look at this article by Teacher Dazhao. This article, if you want to improve yourself, then you may need to read all of Teacher Dazhao's articles. You probably need to read all of them. You should mainly be referring to this one. That is, his entire set of UE5. Inside UE4, UE5, all need to be read. There's no need for us to repeat it all over again here. Because this is the more essential part, we'll just briefly go over it. Then we'll talk about how to actually use it. So how do you create it? Actually, you just need to inherit the corresponding subsystem after inheriting it. Then this instance, the engine will automatically create it for you, and it will have initialization and shutdown phases. It will expose two methods for you. you can override them, right? And the reason for using subsystems is obviously to reduce our programming time, and you don't need to override engine classes. Then you can also do it in Blueprint. Use syntactic sugar to access it conveniently. For example, if you type subsystem here, you'll see these are some syntactic sugar provided to us. Look, there are many subsystems here. The engine has already started doing this extensively. You should keep up with the engine's pace. And write in this way. This approach also allows Python to access it and encode in C++ code. You can also write it this way. This essentially lets you focus on how to use the plugin without having to worry too much about when this system is created or what is destroyed. You just need to follow its rules. This part is accessed through Blueprint. Then let's look at this part, which is accessed through Python. Then this is its lifecycle. This is tied to the engine's lifecycle. Yeah. Then this is how to obtain it. If you are inheriting from the engine, then you'll pass a template here. Then obtain it through the GEng method, and this is the editor. If it is the editor, you need to obtain it through the GEditor method. Then if it is GameInstance, we mainly use the GameInstanceSubsystem because most of the logic we write is tied to our game, and we generally don't load the engine. If you have a need, you only load the engine or do it in the editor. For example, if you want to develop these editor tools, or if you want to extend a certain function of the engine, you need a different loading timing that is earlier and faster. Then we generally do it on the game instance. As for this local player subsystem, it mainly uses this ULocalPlayer method to achieve this subsystem of the local player. So here it gives a simple example, which is an application instance. For example, on the game instance, you can add a description of a resource, add resource statistics, the save load of the aggregator. So actually all this code, you can move it all to UGameInstanceSubsystem. Then your game instance will be very clean. So this is actually a kind of composition thinking. And then due to certain reasons, they can actually be separated. That is, they don't need to keep references to each other. Relationships like responsibilities, because during their respective instantiation periods, is controlled through the engine standards. So after you create it in this way, then you follow the rules of this game instance and continue using it in a streamlined manner. Okay, so so such a subsystem of a game instance, its definition method is actually quite simple. This part is your business logic, and this is some of the interfaces it provides for you to override. Then you may have some resources that you need to read locally. Before the system starts, access some web links, and then generate some instance objects. Then when the game ends, you want to release these resources. Then you can write in these two override methods. The timing of calling these methods, you can call them in the C++ blueprint. Okay, so a subsystem is actually a singleton. You can think of it as a lightweight version of a game instance. That is perfectly fine. Good. So we will briefly cover this lesson here. Actually, we will add more details later, because in this chapter, we only instantiate it, apply for this thing, and then explain some of its features. As for the actual practice, just around the time, we should be at about 15 sheets. We will make extensive use of smart pointers and multi-threading system designs. Okay, we'll stop here.